Unit 1.3 is all about what's called atomic structure. And atomic structure, don't let that mess you up. Atomic just means, look at the first four letters, just means atom, and just atomic structure simply means the structure of the atom. So in the 1800s, there was a gentleman by the name of John Dalton, and he kind of came up with some ideas about these little tiny particles. And so one of the things he came up with, he said, we think that every single thing that is made up on this earth is made up of elements, and those elements are made up of atoms. And he also thought that all atoms of an element are identical to each other, which today we know is not 100% true. There are some things called isotopes, which we're actually going to learn about in our next lesson. That makes the elements a little bit, or the atoms a little bit different. Okay, he also said that in chemical reactions, atoms are not changed, and typically they are not. That is true. The only time where that may not be true is if you have what's called a nuclear reaction, where the nucleus of the atom changes, and that does change the atom. But again, in general, the general rule is in a chemical reaction, in a normal chemical reaction, the atoms aren't changed. The atoms might change position. They might break away from one atom and join another atom, but the atoms themselves are not changed. And then the final thing was that atoms are the basic building block of all matter. So all matter is based on atoms. Now, like we said, atoms are not changed in a chemical reaction. Again, most chemical reactions, okay? So what that means is it means that every single atom that you start with in a chemical reaction, you also end up with the same amount of atoms, which means that the mass of the reactants in a chemical reaction has to equal the mass of the products in the chemical reaction, because again, no atoms are destroyed in these chemical reactions. And this law is called the law of conservation of mass, which means that mass is conserved, which means that the mass of the reactants, of the total mass of the reactants, has to equal the total mass of the products as well. Okay, so for example here, let's say we have 3 grams of water. So we've got 3.00 grams of H2O. And it's going to decompose via what's called electrolysis, and you get 1.73 grams of oxygen. Okay, the question is, what mass in grams of hydrogen was produced? Well, we know that the total mass of the reactants is 3, and therefore the total mass of the products must also equal 3 grams, because every single atom that's here has to also be over here on this side. And so we can figure out how much hydrogen was produced by taking the mass of the reactants and simply subtracting the mass of one of the products. And then whatever is left, 1.27 grams, that is the mass of the hydrogen. Okay, so the mass of the reactants, 3 grams, has to equal the total mass of the products, 1.73 grams plus 1.27 grams gives us our 3 grams. Okay, in the second example, it says iron, 5 grams of iron. So we've got 5.00 grams of iron completely oxidizes, producing rust. And it says 7.14 grams of rust. Okay, so if we start with 5 grams of iron and we end up with 7.14 grams of this rust, the question is, what mass of oxygen was used? So the question is, how much of this did we need? So again, the mass of the reactants must equal the mass of the products. So since the mass of the products all total is 7.14, we can subtract the mass of the iron, 5. 7.14 minus 5 is 2.14 grams of oxygen. And that is our correct and final answer. Okay, now the modern view of atomic structure means this is what we think right now. Could this change over time? Absolutely it could. But this is the modern view of atomic structure. Is we know a few things about the atoms. So, and there's this whole paragraph here, but honestly it's easier just to come down here to the table and then this picture here. Okay, there's a few things that we know. First of all, we know that the atom is made up of protons, neutrons, and electrons. And you can see right here that the protons and the neutrons, where are they found? They're found in the nucleus. Okay, so the center of the atom is the nucleus, and that's where you find the protons and the neutrons. And then outside of the nucleus, Notice right here, outside the nucleus, the electrons are found. And a lot of times we think the electrons circle the nucleus like the planets kind of have that ellipse around the sun. Okay, that is not correct. The electrons don't move in a circle. They just move randomly around within different energy levels within the atom. And we're going to learn about energy levels here in a while. Okay, so the protons and the neutrons, notice that again, come back up to the table here. The protons have a charge of +1. Okay, the neutrons, think of neutral. Neutrons have no charge, they're neutral. And then electrons have a charge of -1. And in all atoms have to be electrically neutral. So if you have 12 protons, then you also have to have 12 electrons so that the positive charges and the negative charges cancel each other out. Notice that many times when we write protons, we just put P with a little plus up in the corner. Again, that tells us that protons have that positive charge. And electrons have that little negative charge up in the corner, again telling us that electrons have a -1 charge. Okay, and the only other thing you need to know about these three different components is this part right here. Okay, notice that, again, this is called scientific notation. And for right now, the main thing that you need to know is that -31 versus the -27. And again, don't worry about what those numbers actually mean, but what you need to know is that electrons have a mass that's about 2,000 times less than the mass of the protons and the neutrons, okay? Which means that the electrons really have no effect on the mass of the atom at all. The mass of the atom is almost entirely made up of the protons and the neutrons. So one of the things that we say many times is that the protons and the neutrons make up the mass of an atom, but the electrons, again, where are the electrons? The electrons are all this space out here. The nucleus is this tiny little thing here in the middle, and then you've got these electrons taking up lots and lots of space. So the protons and the neutrons make up the mass of the atom, but the electrons make up the volume. They're the ones that take up all the space in the atom. Okay? Now, using that information is now we can actually look at an element on the periodic table. And you guys hopefully saw at the beginning of this module, there is a periodic table there for you to use. I simply pulled this from that periodic table. Okay, so as we said it earlier, protons and neutrons make up the mass of the atom. And again, they take up so much of the mass that we don't even consider the mass of the electrons. Because again, they weigh 2,000 times less. Okay, it's like a little piece of lint lands on my hand and then I go weigh myself again. Is that going to change how much I weigh? No, of course not. Okay? Now, every element on the periodic table has a number on the top here and a number on the bottom here. Okay, this top number is what we call the atomic number. And the bottom number, there's lots of different ways to call this. One of the ways is just to call it the atomic mass. Sometimes it's called the mass number. Sometimes we're going to refer to it as the molar mass. But you'll notice that every name has the word mass in it. So it's either the atomic mass, the mass number, the molar mass. Okay, but really what you need to know is the atomic number. What does this number here represent? Okay, the number one thing that it represents is it is the total number of protons in the atom. Okay, and in general, it's also the number of electrons, but not always. We're going to learn about that later on. Okay, for right now, all you need to know is that number on the top is always, it never changes, the number of the number of protons. So remember these things here in the middle here, the little red ones here, that's the number of protons there in the nucleus. Okay, so for example, for the element carbon, every single carbon atom that exists has 6 protons. Okay? Now, again, when an atom is neutral, sometimes it's not. We'll learn about that later on. So for right now, we're going to assume they're all neutral. Okay? So if there's 6 protons, that means there's 6 positive charges. And remember, the atom has to be neutral. So if there's 6 positive charges, there also have to be 6 negative charges. So that means there's also 6 electrons in that atom. Okay, now the atomic mass is this number here on the bottom, And that number, when you round it to the nearest whole number, is the sum, and sum means add. So the sum of the protons and the neutrons put together. Okay, and it is the number on the bottom on the periodic table here. Okay, so in this case, we round that to the nearest whole number. The nearest whole number is 12. And that means that that number 12, that's the number of protons and the neutrons put together. So since we already know that there's 6 protons, we can take 12 minus the 6 protons. And what that does is it also tells us that in this case, there's also 6 neutrons. Okay, now in this case, yes, there's 6 protons, 6 electrons, 6 neutrons. Oh, they're always the same number. No, they're not. Okay, for right now, for this very first example, just to make it easy, yes, it was 6 for all 3 of them. But that is not always the case. Okay, so a carbon with an atomic number of 6 has 6 protons, 6 electrons, and therefore it also has 6 neutrons because, again, 12 minus 6. So when you're determining the number of, here's a fancy word for you, subatomic. Okay, that means smaller than the atom. So that means that the little particles in the atom, which is just a fancy term for protons, neutrons, and electrons. Okay, you can use that method. Okay, how do you know the number of protons? Again, the number of protons is always equal to the atomic number. And again, for right now, we haven't learned anything different, so it's also the number of electrons. Okay, and the atomic mass, like we just said, round it to the nearest whole number, and then that number is the protons plus the neutrons put together. And then like you saw me do, to determine the number of neutrons, you subtract the number of protons from the atomic mass, and that will equal the neutrons. Okay, now sometimes you'll see it written, I kind of skipped over that part. Sometimes you'll see it written like this, or sometimes even just like this. Okay, and what that means is it means that carbon, again, has a mass of 12, which you already know from the periodic table. But again, we're going to learn how that number can change sometimes here, maybe tomorrow or the next day. Okay, so I'm telling you that the mass of carbon is 12. And again, this number here really doesn't need to be here because it never ever changes. Okay, carbon, you know, if you look at the periodic table, it always has an atomic number of 6. And for right now, that 12, we're going to keep that at 12 for now, but that will eventually change. So here in example A, it says determine the number of protons, neutrons, and electrons by using the information that's here or using the information on a periodic table. Okay, so this is the element phosphorus, and phosphorus, the number on the bottom is 15, so that's 15 protons and 15 electrons. And then we take 31 minus 15, and that gives us our 16 neutrons. Okay, for letter B, notice that letter B, I don't give you any numbers. That means you have to go and look at the periodic table. You have to find iodine on the periodic table. I think you're going to know it's number 53. So pull up that periodic table that I gave you at the beginning of the module, and you'll see that iodine is number 53. It has a mass of 126.9 something, something, something. So we're going to round that to the nearest whole number, which is 127. And then we subtract the protons, and we get 74 neutrons. Okay, so that's how we came up with that number, and then 53 electrons, because it's the same as the protons. Okay, at this point, go ahead and pause the video and try these other 4, and then I will go over these with you here in just a second. So pause now. Okay, so for letter C, we've got, this is the element mercury, and I said 201 and 80. So that means it has 80, notice the abbreviation here, P plus means 80 protons. Okay, and we also know there's 80, not 8. We also know that there's 80 electrons, and then 201 minus 80 is 121 neutrons. Okay, for iron, I go to the periodic table. I see that iron, oops, I closed my periodic table. Hold on here just a second. Let me pull it back up here. So just to make sure we're all looking in the right spot here. Not that. So periodic table. Oh, I must have deleted it. All right, anyway. Iron has an atomic number of 26. So find number 26 on the periodic table. That means it has 26 protons, 26 electrons, and the atomic mass of iron is 55.8 something, so we're going to round that to 56. And 56 minus 26 is 30. So iron has 30 neutrons. Okay, and then letter E, identify the element. Again, what's the only element that has 17 protons? Must be chlorine. So Cl, and then the number of protons, neutrons, and electrons in chlorine, certainly 17 protons, 17 electrons, and 35 minus 17 is 18 neutrons. Okay, and that is it for that unit.